All right, everybody, here we go. It's lab time. Welcome to Earth Science, of course. It's lab time for finding epicenters. You got some text here to kind of talk you through a little bit. If you forgot, although I think the videos are going to be a little easier to deal with. Please note, this is just like an example saying, hey, here's how you do it. Don't be the one student every year that tries to use this one. I guess that'd be a lot harder on a computer screen, so maybe that won't happen. When this is on paper, every year somebody tries to actually use this little graph, and it doesn't work. Use one of the reference tables that we have been using, and you will be okay. So we got Chicago, Tampa, and Wink. When did the P wave arrive? When did the S wave arrive? What is the difference in those two times? And then how far away is the epicenter? Again, you've done this using this reference table. And on your survival guide, if you forget, go back and watch those two videos that are highlighted. And if you haven't done all the work that leads up to this, I really don't recommend going forward. At this point, your classwork here should be done and ideally checked by me before we move on. If that works out timing-wise, which we should be able to make it work. Okay. So get that distance, and then how far did the P wave travel? The travel time. How long did it take to travel? And therefore, we could figure out when the earthquake actually occurred. If you do your work right, it's only one earthquake. So all three of these numbers right there should be the same. Now, might they be off a little bit because of there's like three different places where you can make little tiny errors? Yeah, that might happen. If they're wildly different, we might have an issue. If they're similar, I think we're going to be, that might be a good self-check that you're on the right path. Okay. All the way down here is where you'll find the seismograms. I recommend blowing it up to get a pretty good view of where it is. And I definitely recommend on this one doing that line trick, maybe even with the straight line tool. Like that. And you can move, and in fact, we're going to need to do this in a minute. You can move that line using, if you click to this little pointer tool right here. Okay. Each one of these, so this is 230 on the dot right here. 231, 232, 233, 234, and then 235, right? So each one of these larger lines, I'll erase some of my noise here, is 1 minute. And then each of these is 10 seconds. So you can really get it down to the nearest 10 second, I think, pretty easily. I wouldn't try to do anything that's not rounded to the nearest 10. You're welcome to, but might make life complicated. Your call. So yeah, to the nearest 10 seconds, you should be able to get those all fairly easy. Plug them up into these numbers, and you're going to be all set. Okay. There is, however, one new concept today. And it's called triangulation. The idea is, if I were to tell you, let's say there was a pot of gold a certain distance away from New York, say, 500 miles away from New York. Where could it be? If it was 500 miles from New York, it could be anywhere on a circle that's about 500 miles in diameter. Is this 500 miles? Probably not. But as a quick example, it could be anywhere on that line, which isn't super helpful. So if you do it with a second city, those two are going to intersect. Let's do it. What the heck? We got time, right? You're not sick of my videos? Let's say it's this far from whatever city might be right about there. Now it can either only be in that location or that location. And then once you do a third, it'll intersect at exactly one spot, that being the spot where my pot of gold is, right? Triangulation 3. If you do this with 3 cities, you can draw 3 circles, and where all 3 of those circles intersect, you've got yourself a location. So we can do that in this lab. Now, I haven't done it yet. I don't know the answers off the top of my head. But what I'll have you do is once you get an answer and you put it in here, the distance to the epicenter, you're going to then draw a circle of that diameter using this kilometer thing down here, and then bring it up and throw it on the map. So, Mr. F, how do I do that? Let's pretend that it's Memphis, and I'm going to make up 1,000 kilometers. And I'm deliberately not using a city that's on there because I'm saying that this is not the answer. Here's how you would take 1,000 kilometers and do it in this lab. I'm going to go a little bigger. All right, I need a circle with a radius of 1,000 kilometers. So if you draw it, and once it's on paper, you got to switch over to this arrow tool. Then you can monkey with it. This might take a little bit of goofing around, but I need to get it to a radius of 1,000 kilometers. That's too big. So I'm going to need to go smaller. It's got to be a circle. Do your best to make it about a circle. That little crosshatch right there is pretty handy. All right, I'm still just a tiny bit too big. So this is, I recognize that this will be a little frustrating at times. But monkey with it, monkey with it. Let's see if we got it. I'm thinking that's pretty good. See, when I click and I hold it, that crosshatch, I got that right on 0, and I got the radius right on 1,000. So if in this lab, it said it was 1,000 kilometers from Memphis, then all we're going to do is drag this circle over to Memphis, drop it on there, boom, you're done. Okay? So whatever those 3 distances are, do that with those circles. And they got to be pretty round. If you have one on there that looks like this, I'm going to say that didn't work, because it's got to be a consistent radius all the way around. And if everything worked in this lab, all 3 of those should come together in one spot. Pretty close to one spot. If you get them all exactly on one spot, especially with a Chromebook and all of that, I'd be pretty impressed. Because think of the places where you could have errors. You could maybe read those wrong. You could do the graph like a little bit off, a little bit at an angle. That might cause a little error. Same thing here, and then same thing here. So that's like 5 sources of error by the time you get to drawing these circles. So I'd anticipate that they all don't hit an exact spot, but that they're close-ish if you've done things right. Okay? Sound good? That might require a rewatch too, to see how to play with those circles. But use this arrow tool. That was the handiest way to do it. All right? Move it around, size it up over there, looking for a radius that matches these distances from those 3 cities. Okay? How are we looking here? We did notes on that? You can do it. That will be, once you do the map, tell me about where it is. Why is 3 the minimum number? I guess it's kind of awkward to explain. But with 1, it could be anywhere on a circle. With 2, it gets down to 2 spots. And the third gives you where 3 spots intersect. That's called triangulation. This is an interesting concept, number 4. And it's one that maybe I haven't mentioned specifically yet. Though it's been implied, certainly, if you've made it this far. Why is it that the gap gets bigger and bigger and bigger? And that's going to be a continuing trend. The further the distance is, the bigger that gap is. The more it travels, it's like more of an opportunity for the faster thing to get ahead. All right. I often use an example of a race. If I were to race one of you students in class, who in all likelihood is faster than me, I usually pick somebody in class that's like on the track team or something. Though most of you are probably faster than me. If I were to say, let's race, and let's race just across my room, you're going to win. Maybe by a second, half second, somewhere in that range, right? What happens if we make that race longer? What happens if we race the whole second floor hallway? You're going to win again, but by a larger margin, because the more we travel, the more time you have to get ahead of me. And then let's go outside and do the mile. Yet again, you're going to win, but by an even larger margin. So the more distance gets covered, the more opportunity there is for these 2 different speed waves to separate from each other. Just be quick on this. What were the steps you did? I don't know. You don't have to write a book. I know there's a lot of space there. But I think if you made it this far, and you can give me a very brief, concise, hey, here's what I did to do this, then we're going to be good. And that's good. That's good. That'll be good. That's it. And if we did this, I'm going to try to do one more like quiz check and see if we all know what we're doing. But you have fought your way through probably the hardest lesson in all of Earth science at this point once you finish this lab. Not when you finish this video, unfortunately. So congratulations. Thanks for your hard work. And we will see you soon.